So here we're given a function f of x, a polynomial actually, and we would like to find another function whose derivative is that given polynomial. We call such a function an antiderivative for our polynomial. And pretty much the idea is that we're really trying to find a mystery function, let's denote it by a question mark, whose derivative is 5x cubed plus 4x squared minus 3x plus 7. Let's explain the mechanism. And because the derivative behaves very nicely with respect to sums, we really look at each component separately. So we try to find a function whose derivative is each of these components and then add them all up. And in particular, we actually focus on the corresponding monomials, like so. Because if you want to get such a monomial as a derivative of some function, then what you need to use is 1 power higher divided by exactly that power. And the reason for that is because if you take the derivative indeed of x to the n plus 1 over n plus 1, that's the same thing as taking the derivative of 1 over n plus 1 times x to the n plus 1. And again, derivative respects multiplication by a constant number, so that will be 1 over n plus 1 times the derivative of x to the n plus 1, which is 1 over n plus 1 times n plus 1 times x to the n. Remember, to take the derivative of a monomial, you multiply by its degree and you take 1 degree lower. So these two things cancel each other and you indeed find x to the n. So that's precisely what we would like to do here. So to give the solution of this, f of x will be, so we preserve the 5, and then for x cubed, we go 1 degree higher, which is x to the 4th, and we divide by 4, which is the same as this. Okay, so in other words, this is an antiderivative for x cubed. And then we have 4 times the antiderivative for x squared, which will be 1/3 x cubed, minus 3 times an antiderivative for x, which will be 1/2 x squared. And finally, we will have 7. Think of 7 times 1. The antiderivative for 1 is x. So you will have 7x. Sometimes here people ask, do we have to put a plus c? And the answer is, if all we want to find is just an antiderivative, there is no reason for putting something like this. You can leave it like this, or you can just multiply those coefficients in front and write it this way. Either way is perfectly fine. And that's the antiderivative that we were looking for. That's all. Thanks for watching.